Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. Can you tell me about DSPy, Assert and Suggest? How to programmatically guide large language models? Today, we are going to look at test-driven LLMs and creating second eyes using Assert and Suggest in Python DSPy. So that's our goal for this particular discussion. What we are going to dive into right now is to first of all see how to install DSPy. One of my viewers had requested to tell me how the installation happens. In case of DSPy, you can use this pip installation process that has been provided by the DSPy documentation. Before you do this DSPy installation in your environment, what I would suggest is that you can first of all create a virtual environment. Let me zoom in a bit using Venv, and I can say test DSPy as the virtual environment name. This will create a copy of your Python installation inside as a virtual environment on your D drive in your root, and from there you can activate this virtual environment and then you can install this option. So I prefer to install the DSPy along with the ChromaDB or any of the Quadrant, ChromaDB, Marco, MongoDB, any of the additional databases for vector storage. Even though most of the examples that we will work is we are using the retrieval model from that has been provided by DSPy guys itself, the Stanford NLP guys, that is Colbert V2 server. But if you are going to have your own local retrieval model, then you can use this option. So let me go back. The virtual environment has been created, so all I need to do is I need to use this scripts folder and I need to activate. That will activate my virtual environment. If I do a pip list, you'll see that it has got only two libraries. One is setup tools and another is pip, and it is also asking me to run this command. So let me run this command so that it will upgrade my pip. The reason we are upgrading the pip, it is going to work with the updated database of Python libraries. So if DSPy or any of the new Python libraries comes up, this pip 23.12 will be 24.0 will be able to properly pull it and do the installation. Next, what we are going to do is I'm going to do a pip install DSPy-AI and I am going to say ChromaDB. In this case, what will happen is if you're using Linux or if you're using some other operating system, then probably you need to use a double quotation like this, because the square brackets may not be acceptable in certain terminals, so it can actually error out. So if I execute this right now, most probably it will take my cache. Yeah, it's actually downloading. Yeah, here it's taking the cached libraries and it is installing it in my new virtual environment also. Most of the time it is taking cached, but couple of time it is actually downloading the updated libraries also. So whichever way it is, once the installation is completed, all the necessary libraries, modules that you need for the DSPy examples will be installed. So this is how the installation process works. So just in case if you guys are new to this, if you also go back to the installation process and if you go to the collab notebook, in case of the collab notebook, the DSPy guys have used multiple steps or multiple checks, I should say, before they complete the installation process. So they try to do the installation through the repo, that is the GitHub repo itself. And if that repo does not work, if the package resources does not have the DSPy-AI, then they do the pip installation of the DSPy-AI here. That's what you are seeing in the collab. And this is what I was telling about. The DSPy developers, the Stanford NLP group itself has provided the retrieval model called Colbert V2, and they have given the URL also. So this URL you can use for most of your experiments with the DSPy library that I've already done till now. So that is a small detour on how to install DSPy libraries. So I hope that was helpful for you. in case of the ChromaDB and in case of the DSPy-AI supporting documents, a lot of additional libraries will get downloaded. So be aware of this and ensure that you have sufficient time and sufficient bandwidth for that. Once everything is done, then you can move to the next step. So let it install. So here you can see that's a lot of libraries that is getting installed, right? And as you can see here, these are the two libraries that we asked for to install, but all these came together because ChromaDB will require various other supporting models for doing the embedding. Same way, DSPy-AI also will require supporting libraries that will be connecting with the external resource, or let it be connecting with the internet based vector stores, or trying to connect with telemetry related applications. All these supporting libraries or modules gets installed in a single go. So that's one of the benefits. Let the installation get completed. As the installation is taking a little bit of a time, I'm going to jump into the DSPy library right now, and we are going to start discussing about what DSPy asserts and suggests do. This notebook that you are seeing here, it's a composite notebook that introduces all the modules of DSPy in a single notebook, and it does it in a fashion where the purpose of a particular module or particular part of DSPy does, and then the respective code execution is also shown in the bottom. In case of DSPy assert and suggests, it's pretty simple. These two modules, or these two classes inside DSPy, they guide the LLMs to provide the output that is required by our application and our domain specific constraints. They exactly try to coerce the large language model. It cannot force it, but it can try to give instructions to it, try to update the prompt a bit. It can try to provide additional support instructions. All these things, it is done, but it is done automatically. But how it is being done, that's one of the important points I wanted to highlight. So some of the examples, how the reply must be structured. So you might want the reply to be structured in a particular fashion. The reply might be having a constraint that, okay, it should not contain certain content. You might want to filter it. How long is the reply? So you don't want the model to keep on rambling. How well the reply is formed. So these could be the kind of use cases that you can work with DSPy suggest and asserts. Objective is pretty simple: to have a top class reliability, predictability, and correctness when it comes to large language models. That's the objective. But how are you going to achieve it? So there are parameters, as all the DSPy parts of DSPy that you have come across, they have some kind of input parameters and output behaviors. So does assert. So here I have created a simple dictionary of Python that introduces assert. It introduces its parameter. The parameters are the constraint that you are going to give, the message that the assert is going to throw, and the number of backtrack that the assert can go through in case if there is a failure. So these are the three major parameters. So what are the constraints? What is this message? What is this backtrack? I'll be explaining all these things to you with an example. Then comes the behavior. So when it comes to the parameters, assert and suggest have very similar parameters. In fact, they have the same parameter. Only the behavior is different. In case of assert, it initiates the retry, and upon failure, there is a dynamic modification of the signature, right? But it halts. If there is no improvement, it halts the execution. That is one of the key aspects. It add fields like past output and instruction in which the way to recover is provided. However, if there is no improvement, it halts. On the contrary, the suggest keeps on proceeding further, and it logs the failure after backtracking attempts. It does not stop. The point here is that it actually encourages self-refinement. The idea here is that it takes a bit of more calls to the large language model in case of suggest, but it tries to get the output. So that is a difference. The idea is that if you are going to use if you're going to work on development related activities, it is better to use suggest if you're using if you're in evaluation phase and development phase. But if you're going into production, it is always used to use assert as the gatekeepers and checkers. Now you guys might be completely new to assert and assertion process itself. So there is a complete video that I've made on test driven development. You can take a look at that video in this particular link. The DSPy assert and the Python assert, the actual Python assert, is not very different. So let me show you something. I'm going to execute this particular cell right now. And the moment I execute this cell, you'll see that it is going to take a bit of a time, and it is going to say that there is a name error. There is a red name error that is coming, and if you scroll down, it is saying that the name add math is not defined. What this assert is doing is, first of all, this assert keyword is inbuilt Python keyword, and it is actually running this particular function. If it is available, then it will give the input 5 and 8 to this function, and then it will check whether the output of this function that is returned by the function is equal to 13. If not, then it will say function fails with the error. In this case, if you see at the bottom, the name itself is not available, so the function did not execute. So this particular command line itself did not work. Now let us do something else. So let us actually go up here, and instead of actually doing a return like this, we are going to pass it. So meaning we are going to now remove the name error. So this will remove the name error, but this will have the function fails with the error, because this function is not returning anything. But here this assert is expecting that this function will return something, and we can check that value with it. So okay, now in order to circumvent this error, so you see that this function fails with error is getting printed here, and it is saying it as assertion error. So this is the first purpose of assertion. So without you looking at what is the input and what is the output, the program, the Python code itself does the work for you, and it tells, okay, the function is failing with the error. It's informing the user. In order to mitigate this error, all I need to do is get the return statement out, and let me comment this pass. And if I execute it right now, you'll see that there is still an error. The error right now is in 11th statement. So it is in 11th statement, 11th sentence. Here, the first 10 statement has got through. It has able to execute both add math function, and it has been able to pass number 5 and 8, and it is able to also check that the output is 13, and this particular error did not trigger. But in this case, it actually had triggered the error, because we know that if you add 5 plus 8, it's going to be 13, and it's not equal to 23. So because of this mismatch, the error is getting thrown, and instead of telling that it's mismatch error, it says that function fails with the error. So this concept of first of all writing the test, you just take a step back and look at what I did. This particular function was initially commented out, right? And then I executed the cell. There was an error. It was a name error. After that, I uncommented the definition part of this function, and I gave a pass for this function. After that, the name error left and assertion error came in. So we knew that, okay, the function is not returning anything. After that, we gave the return statement. Then the assertion error for this line got removed, and the assertion error for statement 11 got introduced. So this concept of writing the tests first, because we wrote this test first and then we started writing the function. This is called as test driven development. And this way of writing tests, meaning that you first decide that, okay, if I write a function and if I give an input 5 and 8, the function has to give an output of 13. It should not give anything else. Inside the function, whatever you do, it doesn't matter. Whether you return just 13 number always, it's your call. But at the end of the day, this is what my my end result should be. So that's what I am telling ahead of time. That is called as test driven development. Usually we don't actually hard code any of the return statements. We are developers, we put some kind of logic inside the functions and we get a good output for any kind of inputs, right? So the idea here is that test driven development, the tests are written first and then the development is done on the functions. The same kind of activity we can do with large language models also, and that's what we are going to see next. So before we dive into that, let us look at the installation. So here a lot of things have got installed, right? And if I now do a pip list, if I do a pip list, you will see that a lot of things have got installed and all the libraries and their versions also will be shown here. So you can do a pip list and you can pipe it, or you can redirect it to requirements.txt, and you can share this with your colleagues for installing the same library also. So same libraries also. The point here is that this is how the installation process is completed, and after that, when you are in VS Code or whenever you are in your IDE, you need to go and select the appropriate kernel. So if you come here, if you go to the okay, in case of VS Code, what you need to do is you have to use Control-Shift-P, go to Python select interpreter, scroll down, select the workspace level interpreter, and then enter the interpreter path, then find it. So once you go to find, then you have to go to D drive and locate the interpreter path. So that's how you do the entire process. So I hope that you guys have got some clarity right now of the three things: how to install DSPy-AI and what DSPy asserts and suggests are doing, what are the parameters and the behaviors. Also, we saw the basics of test driven development, not a full in detail dive in, but we have seen the basics of it. If you are still interested with this red green refactor pattern that I introduced, you can take a look at this video. So I have provided a in detail red green refactor method for developing a linked list data structure. It's used even today. Even today the test driven development is used widely, and even I prefer a couple of times to use the test driven development whenever I'm working for customers. So what happens is that there will be a critical specification that the end user will want, and it is always better to fix that critical points as function outputs and then write the function accordingly. That will save you a lot of time in testing the functions. You don't need to every time write the function, see whether what is output. So you can actually have a script and you can run the function on top of it by importing and using PyTest. It is really fun to work in that way. Anyway, so that is for another one discussion. Let's move forward. What we are going to do right now is we are going to dive into the code of DSPy asserts and suggests. This is where I'm importing all the necessary libraries. I'm importing print from Rich. Rich is one of the modules that makes the printing of stuff inside Python library pretty interesting to look at. We have OpenAI SDK. We have .env that loads the API keys from OpenAI and loads it into environmental variables inside my operating system. That's what it is doing. Let me execute this. Next, what I'm doing is I'm importing all these mod classes as well as in certain cases functions from DSPy. OpenAI is for connecting with OpenAI ChatGPT models, GPT 3.5 models. Signature is for providing signature to predict classes. Predict and chain of thought will help to get the generative outputs or large language model outputs from the ChatGPT like models. Input field and output field help the creation of signatures, and then we have suggest and assert. That's our main discussion classes. And then we have module helps to create programs in DSPy. There is a separate discussion on modules. I would suggest you guys to take a look at that before you start. I mean, there is a separate videos on all signatures, large language model connectivity on module. All these have been separately covered. Take a look at those, and also you can scroll this notebook also. You will be able to see the examples that has been given for each of these parts of DSPy library. Because I am saying parts because in case of DSPy, there is something called as module also. In the module here is a class inside DSPy, so it can actually confuse with the Python modules. So that's why I'm saying it as DSPy parts. Fine. Now that we have got this in, we will execute that, and we see that the import has been completed. Next, what I'm going to do is you can test the turbo model that you can connect with the OpenAI ChatGPT 3.5 turbo. You can test it out. By default, the history will be 0 when you begin with. So let me execute that. But there is a different way to start this also. So let me show you that in the later part. So the history or the calls that we have done with this particular object that we have created, that is turbo object, is as of now 0. So it's a fresh object. The reason why I'm saying it is a fresh object is because we have not made any calls and it has not got any history. Next, it's a very basic predict object that you are creating, where the input will be a question and output will be a response. This is the first thing that we are going to try. So let me go ahead and create this object. So this predict object will help to connect with ChatGPT or GPT 3.5 turbo and get me the output. So here I have tried to do the same thing with Gemma Olama. That is a separate discussion, and you can also do the inspection on that. So here I am trying to do that with turbo model, and once I execute this turbo model, you'll see that the output response is coming along with the question. So it is giving me the question, and then the question that I provided here, and then it is giving me the response. Even though the response that I want is still fine, but I don't want this question to come along, because I will show you the challenge later. So let me proceed. So if I split the response, you'll see that I have the question and then the response, and the response object with 3 questions that I've asked for. In order to change the behavior, so I am going to create a new signature which is called as only response. In this case, I am instructing. So this is the instruction I am giving it to the language model through the signature. Reply the question with a list of replies. Okay. I'm telling reply the question with a list of replies. Don't attach the question. So that's what I'm trying to say. And here in the input field, I am telling this is a question, and output field, get the replies as a list. So these are the kind of description that I'm giving it a signature. After that, I'm going to again create the same kind of a predict object here. So if you go up, I created a predict object here. Here it is an inline signature. Now I have created a more detailed signature using the class, and I'm sending that signature into the predict class, and I'm getting a new pred_list object. And I'm again using turbo, and I'm trying to get the output. And this time you'll see that the output that I get is not containing the question. So basically I've removed the question by telling the model using the signature that I don't want the question to be included in the replies. So this is one of the ways where you can control DSP, control the large language model outputs. However, there is one catch. In what you are seeing here is that I am sending only one question here. So provide me 3 questions about Paris, and it is giving me 3 questions without any kind of a challenge. But what if you decided to have some 100 different questions like this, and you started connecting the chat GPT 3.5 turbo model and look for same kind of result, meaning 3 questions. There is a high chance that for a couple of questions out of that 100, the answer may not be this kind of list. It can be something else altogether. How will you know that? Actually, you will not know until unless you execute this. Until unless you execute that entire set of questions and see the output, you will not know. But executing that kind of output and looking at a result which is not matching your requirement is going to be very frustrating. So one of the ways you can avoid or mitigate this is by actually writing a simple function. The function is similar to the assert function that I introduced here. So if you go up, I introduce the assert function here, where I tell that I'm going to give an input and the output should be like this. The same thing you can do it here also. So if you scroll down, and here I've written a small function which says that validate is a list of 3. I'm telling that I will be giving you a reply. I want you to split the reply and ensure that the length of that list is coming as 3. So if the length is coming as is returned as 3 from the split data, that means it is a list of 3. You might be wondering, okay, how did I know that I can split with /n? Usually what happens is whenever the large language model returns lists, so it places a new line character at the end, and it places a hyphen in the beginning, or it places a hyphen, or it places an asterisk. You cannot actually split using this hyphens. It might actually get confused with other hyphens or other asterisks inside the text. But the new line characters are usually placed at the end, so you can reliably use the new line character to do the splitting. So these things are kind of a heuristics that you learn as you start coding and as you start solving problems. So do think about the problem that you're solving here. The problem that you're solving here is that it's very simple, that I'm going to send some 100 questions into the predict object, into this predict object, and I'm expecting that all the 100 replies or the answers will be a list of 3 questions like this. But I'm suspecting that there will be some questions which are not. So for that, I'm creating this particular function. Let's now proceed further. In order to use this particular function inside the validation itself, this is where we are going to use the suggest and assert. Usually what happens is when you are going to write a complex program using module in DSPy, you will start by using this creating a new class. So get question answer is a new class that I have written, and here what I am doing is I am doing 2 things. First thing is I will be giving a topic. So you can see that this is a inline signature that I'm giving it to the predict class. So I am not creating a detailed and custom class here, signature class. I'm using a inline signature only. And next what I'm doing is I am creating one more predict where I'm going to give the question and I'm expecting a short answer. So these are the 2 things that this program is going to do, and it is going to do one after the other automatically. So how am I going to do that? It's pretty simple. I will be using a forward method where I will be sending the topic. So this is the topic that will go here, and that will actually get questions. So this topic will be given to the plain predict object, and then it will predict 3 questions or generate 3 questions. The generate 3 questions is going to be checked using the validate is list of 3. So we are going to check that. If it is not list of 3, then the reply must be list of 3 questions. Error will be thrown. So this is one of the ways you can check it. This is the first thing that we check it. Next, what we are going to do is we are going to use the list of questions. So we are going to break this, split the questions that we are getting, and then we are going to run the questions that we get. You'll be seeing the questions also. I'll be printing it out. And so this is the print that you're seeing here. It will list the questions also. And then we are going to generate answers for the questions. And we can look at the answers also. The reason why I'm printing all these things is that you can see why it fails. And now I'm telling in the assert that the answer should be less than 75 characters. And also I'm telling in the assert feedback that answer should contain less than 75 characters. So this is the feedback that the suggest is providing it to the model, and this is the feedback that assert is providing back to the model. How these feedbacks are provided back to the model, that we will see. But before that, we have to see how it fails. What exactly happens when the model gives output that is not matching this assert or not matching this suggest. So let us execute this cell. And now what I'm going to do is I'm going to ask for provide me 3 questions about Paris. The same question which I initially started, and I am initiating an object based on this particular class. So if you guys are new to Python, bear with me, these things are required to be explained. So this is an object that is created from this class. It's kind of an instance or a copy of this class. I shouldn't say it's a copy, but if you are not from the programming background, just assume that it is a copy, because whatever code is there inside this class will get kind of assigned to this getQA variable, and when I run this particular line here, it will execute all these statements. So from this top it will execute all the statements, but only the difference is that this question will be sent in place of the topic. So that's how it works. It's a very very basic introduction for Python classes. And once I execute it, let me open this, let me give it a second, and you'll see that's already an error, and it is saying it's an assertion error. And the assertion error, okay, so here there is no LLM is loaded. So why is the error coming? So let me actually tell you the reason. Before you run this particular code, you have to configure the LLM. In order to configure the LLM, you have to go to settings, configure, and you have to say LM equal to turbo. So this has to be done. If this is not done, then the DSPy configuration doesn't know that there is a language model. So that's why this error had come up. And moreover, this is actually throwing an assertion error, but this assertion error is coming from a different background. So don't think that assertion error and this assert is linked. So don't think that it's from a different location. So let me execute this again right now. Okay, now there is a different error. It is saying that there is a name error, and it is saying validate is list of 3 is not defined. The name error is coming because of the issue that I have not executed this particular function. So now the function is executed, and let me come back here and let me execute this cell. Now you can see that the code is executing. The first question is getting executed. The question is, what is the question there it is telling, and it is also giving me a set of output, but there is a DSPy assertion error. So you see that it is clearly telling it is DSPy assertion error, and if you scroll down, it is telling that answer should contain less than 75 characters. That is because the answer we got here for this particular question is pretty long. We don't want this long answer. So that is how the assertion works. So this way of controlling what the language model is giving and stopping the execution can be really useful when you are going to do in the production. So I see that using assertion in production will be much more valuable rather than using in development. I mean, you don't want the model to stop for all these things, right? So what else can we do? So in order to mitigate these kinds of issues, there is another one option called as suggest. Excuse me. Now before we continue, I want you guys to take a look at the inspection history. So let us go to Turbo and let us inspect the history. So when you inspect the history, before you inspect the history, it's always better to look at the number of history available so that you guys can have an idea. Let me do that also. So length of Turbo, you can actually look at the history in the raw format, but it will be pretty confusing, so I wouldn't suggest you to do that. There are 5 calls, so let us look at all the 5 calls. Right, so here if you see, it's you have to go down, you have to say scrollable element, and now here, okay, so let us come from the top. This is the first call that we have made, and where we are asking for this is where we made the call by using the inline signature. So we used a very simple inline question and response, and this is the output that we got. We got the question along with the response here. This we did not want. So then what we did, we converted, we changed the signature. Now we are getting only the list of questions or list of topics that we are asking for. but the question is not the part of the reply. So this is after we updated the signature. Next, what you are doing is that we are trying to work with, again, topics and questions, but this time we are also trying to check the answers also. So here we are getting the questions, and using the suggest, we already checked that there are only 3 questions or list of 3 questions, and then we are moving into the next step where the first call is made using this question. Using this question. Right, what are some must see abstraction in Paris, and we get all this output. And the moment we get this output, the call loop is broken. There are 3 lists of questions. There are list of 3 questions, but only 1 question got executed. So if you scroll up, and if you look at this list, this for loop, I am actually asking to loop over all the questions in the list. So, and I am asking to print the questions in the list, but we can see that after the first question, this went into the generate answer process. It showed the answer to us, and then it went into assert and it failed. So that's why the loop got stopped there itself. Understanding the operation of the objects is very, very important. So that's why I'm going in detail. I believe that this will be useful when you are doing your development. Next, what you are going to do is, I am going to change, instead of actually having assert. So here it is suggest, right? Here it did not actually throw any error. Even, in fact, there was no error because we had modified the signature. You guys can actually try to, what you can see is that even though here I'm using a very simple topic and questions only. Initially, when I did the same thing, it was not working. But how is this working here? Because sometimes the OpenAI gives a very good response and sometimes it doesn't give. But still, we have this validate option here. Let us proceed further. Now, instead of using assert, I am using suggest. So let us see now what happens. Rest of the logic is same as what we did in the get question answer. So let me execute this cell. This cell is executed. And now again, here what I'm doing is I am configuring the settings with the trace. So this trace is important. I will tell you why the trace is important after completing this process. So let me execute this, let the settings get updated, and also let me show you the configuration. Settings.config. Let me print it, because the print is a little bit better. I think the print will not be better in this case. Let me remove that. So this will show the various configuration, and this trace has to be a list because we are going to add a lot of trace to this particular list. So that's why it's required. Let me clear the cell. I'm going to execute this and let us see what happens. Again, you see there is an error. Why it did not work? So here it's saying DSPy suggestion error. Last time it was saying assertion error, but right now it is saying suggestion error. And again, the same issues being raised. Answer should contain less than 75 characters. But as per our behavior, isn't suggest need to allow us to execute the code? Actually, when you look at the documentation, when you read about it, I was also thinking the same, that if I use suggest, that it will still allow me to execute the code, but it's not. And when I further read about it, when I saw other tutorials, I felt there were 2 kinds of ways to make the suggest works. So one is that by simply using suggest, the code will execute, which is not working in my case. Something I'm missing. So probably if you guys are having some idea, you can let me know. The other way, the actual way that we need to get the things work is we need to use something called as assert transform module and backtrack handler. So that is how you can actually get the suggest to work. But before we do that, let us see what is output. So let us look at the history. There are 2 more calls that has been done, and let us look at the inspection history right now. And I am going to look at 7 outputs. So let us go back, let us go down, and let us make the scrollable element. And you can see that again, so there is a call, there is a first call which gives the list of 3 questions, and then the second call comes in, the question is sent again to the model, and then the short answer is given, which is actually having more than 75 characters, and it fails. Now how to get this thing moving? So there is two more functions called as assert transform module and backtrack handler from primitives.assertion. So this is where it gets imported from. You can actually look at the backtrack handler code. From here I'm not going to show it. You can take a look at that by looking at this notebook. Here there were a couple of ways to use this assert transform module. So one of the methods that is shown in the DSPy what is it called, the tutorials, if you go down, yeah, I think it is in the assertion. Yeah, if you go to DSPy assertions, they try to explain it, they show how it is being done, but actually it doesn't work. If you go as per this particular steps, you have to complete one more step. So then only after that only it will work. So if you see here, this is what they say. So then they say that you can use this assert transform and use the backtrack handler. But the key point is that if you want to use this method, you should first of all have the traces set. So if you don't have the traces set, let me clear the cell outputs. The way we set the traces, if you don't have this set, then it will not work. And the second issue is that if you have to give the backtrack handler the max backtracks. So that also was not taking when I was giving assert transform module. One of the ways that I came across by using this long form QA IPyNB is using this way of using the assert transform model, which I have not fully tried. But one thing that worked was this. So this worked here. I have told us doesn't work, but actually this works. So let us say this works. So here there is a get QA with assertion. So this get question answer has assertion in that. So if you go up, let me do that. Yeah, if you go here, you will see that it has got assert in the code base. And if you scroll down, in case of let me clear cell outputs. Bear with me. And here in the suggest, you will have, instead of assert, you will have suggest. So we are going to test both of these things. And both of these things we are going to use activate assertion method. So in case of get QA with AA, I'm going to execute this cell, and get suggest with AA. So AA is basically activate assertions. I'm going to execute this. So both the objects I have created, and now these objects are basically, these are all programs of programs that run multiple calls to the large language models. And now I'm going to execute this particular cell. So the same question, I have not changed the question, but this time I have activated the assertions. In this case, I have activated the assertions, and let us see how the output is. So let us execute this. Clear cell output. Let me open, and you will see that again it's not actually able to pass. Okay, it is saying the answer should contain less than 75 characters. What happened? Let us actually look at the inspection history. Right, so let us look at the turbo.history, and let us look at the len. So we have 11 calls, and let us do the inspection history of the calls. Let me do this. Now the difference you see here, let me scroll a bit up. Let me scroll a little more up. Okay, so this was the last call where it ended. Now the new call has started with 3 list of questions that has come up, and this question is being sent to the model where it does not give the output. But yeah, just a minute, it does not give the output. But now you see, after the assertion failed, it is actually looking at the past answers, and it is saying that some instruction has to be satisfied. So now there is a modification in the prompt itself, and if you scroll down, you will see the past answer is placed inside the prompt along with the question, and then it is saying the answer should contain less than 75 characters, and still it fails. That's why the assertion stopped. So assertion does not continue to continue further. So that's why this particular code stopped. Okay, now keep that as it is, keep that understanding as it is, and let us proceed to the next step, where we are going to work with get QA suggest with activated assertions. And we are going to use the same thing, but you will see that in case of suggestion, the code executes completely. And if you scroll down, you will see that it is going through the first question once, it is going the first question second time again, and you'll see initially the question answer is, initially the answer is very long, but after that the answer has been shortened. This is the important point. So whatever the suggestion you provided, it was taken by the large language model and it was shortened, but it took 2 more tries, 1 more try extra. And after that, the question 2 worked and question 3 worked, and it is also giving us the traces back that what had happened. Now let us look at the history. You'll see that there are 19 calls. From 11 there is 19, so it means 8 calls have been made. Let us actually look at the output. Knowing exactly what the models are doing, what the code is doing, is one of the key responsibility of a developer. And the more you understand the classes, the code inside the class, how the functions are being called, how the attributes are modified, these things can help you to clearly understand what the large language models are doing. If in case, if you don't understand the code, or if you don't understand the logic behind the classes that is getting executed, then it can actually become a tough task for you. So anyway, so here you can see that the question number 3 is getting answered, and each of the questions you will see that the instruction is also provided and the past answer is there. But anyway, this past answer is not for this particular question, right? We are working for question 3. So this is the last question. If you scroll up, you will see this is the second question. We have it less than 75, and we have the first question here. So what are the top attractions? Initially it was having a long answer, then the answer was shortened. If you scroll up again, I'm going from the back, so keep it in your mind. In the earlier explanation I came from the top, but I'm going from the back this time. So if you scroll up again, here the main answer came up, where what are the top attractions, and we got a long answer. So this is okay, sorry, this was in the assertion case, the earlier case. This is where the first case started in case of the execution that we are right now discussing. So the 3 questions came in, and then the question answer started working. So I believe that you have got a clear idea on how the suggest and assertions are working, and how they are actually guiding the models. Just a minute. So we have seen the both assert as well as the suggest classes, and how they work in DSPy, and how they guide the large language models in 2 different ways. In case of assert, it tries to do the maximum backtrack for once and it failed. If the output is not meeting the condition, it fails. And in case of suggest, it tries multiple times, logs the calls to the large language models, and tries to coerce the large language model to give the output as per the condition. So we saw both of these things, and in that process we actually learned a lot about how the configuration of the large language model should be inside the DSPy, how we need to write the assertions and suggests inside the module program inside DSPy. We also saw the examples, and all these examples were very simple examples. It was not actually complicated with multiple calls to RAG models, or to using evaluate and data sets, etc. It's a pretty straightforward question and answering process that we have seen. Now with this basic understanding, you can start making complex examples, or you can start reading complex examples after you understand this code and execute it successfully. As you already saw here, the parameters between the assert and the suggest were explained, and it was also shown that how the parameter of the constraint, we have to create a function for it, how the message we can write using a string, and how the backtrack can be connected to it using assert module. assert transform module. So we saw the process of that also. Apart from that, in the beginning we discussed about the test driven development and how the DSPy assert and suggest try to coerce the models into to meet our requirement. We saw how the test driven development process is being done using simple functions, how the functions are written after the tests. So this entire process was also explained to you guys. So I believe that in this video you have got a holistic picture of test driven development of large language models and related applications. I'm pretty sure that you guys can use this kind of a format for many of your applications and try to control the output and guide and literally make the applications to do what you want, because you have it in your hand, right? You can use suggests, you can use the asserts, and you can control the output in a very predictable, as you reliable and correct fashion. So with that said, I would like to leave this video with 4 words, that is practice DSPy, practice DSPy. See you guys, have a great time.